Have you ever wondered what actually happens behind the scenes when you run a notebook in Azure Databricks? Where is your code executed? How does Databricks create clusters in seconds? And what exactly are the control plane and compute plane that everyone keeps talking about? In this video, we are going to break down Azure Databricks architecture in a simple and practical way. We will cover what Azure Databricks is, control plane, compute plane, cluster management, job scheduling, security architecture, and finally, a real world architecture example used by enterprises today. By the end of this video, you will understand exactly how Azure Databricks works internally and be able to explain the architecture confidently in interviews, certifications, and real projects. Let's start with the basics. Azure Databricks is a cloud-based data analytics platform built on Apache Spark and optimized for Microsoft Azure. Think of it as a unified platform where data engineers, data scientists, and analysts can collaborate to process large scale data and build machine learning solutions. Before Databricks, teams had to manage Spark clusters manually. They had to provision infrastructure, configure Spark, scale resources, monitor failures, manage security. Databricks abstracts all of that complexity. Users simply write code in a notebooks and Databricks handles the infrastructure automatically. Organizations use Azure Databricks for data engineering, ETL pipelines, data warehousing, streaming analytics, machine learning, AI workloads like lakehouse architectures. But to understand how Databricks delivers this experience, we need to look at its architecture. At the highest level, Azure Databricks is divided into two major components. First is the control plane, and the second is the compute plane. This separation is one of the most important concepts in Databricks architecture. The control plane is managed entirely by Databricks, and the compute plane is where your actual workload executes. Think of it like this: the control plane is the brain, and the compute plane is the muscle. The brain decides what should happen, and the muscle performs the actual work. The control plane is the management layer of Azure Databricks. It is hosted and managed by Databricks itself. Users interact with the control plane whenever they open notebook or they schedule jobs, create clusters or manage permissions, use dashboards and access the workspace. Everything you see in the Databricks UI resides in the control plane. Now next we will see the components of control plane. The first component is Workspace service. This stores notebooks, dashboards, queries, workspace metadata. So when you create a notebook, it gets stored here. The second component is Cluster Manager. The Cluster Manager is responsible for creating clusters, resizing clusters, terminating clusters, and monitoring cluster health. When you click Create Cluster, the request goes to the Cluster Manager. The third component is Job Scheduler. The Job Scheduler handles automated execution. For example, run ETL every day at 2 a.m. or run machine learning pipeline every Sunday, generate reports every morning. So the scheduler keeps track of this task and triggers the execution. The next component is Control Services. So control services includes additional services like authentication, monitoring, logging, APIs, metadata management. All of these services work together to orchestrate your environment. The most important thing to remember is the control plane never executes your Spark job. It only manages and coordinates them. Next, we will see what is a compute plane. Now, let's move to the compute plane. The compute plane is where the actual data processing happens. This includes Spark jobs, SQL workloads, machine learning training, and streaming pipelines. Unlike the control plane, The compute plane is deployed inside your Azure subscription. Next, we will see the components of compute plane. So first component is a driver node. The driver node acts as the master coordinator. The responsibilities of this driver node includes receiving notebook commands, creating execution plans, managing Spark sessions, and coordinating workers. Think of it as it is the project manager. The next component is a worker nodes. Worker nodes perform the actual computations. Tasks are distributed across workers. Each worker processes a portion of the data. Together, they execute Spark transformations and actions. Imagine you need to process 1 billion records. Instead of one machine processing everything, Databricks splits the workload across multiple worker nodes. Each worker processes the part of the data. Results are combined and returned. This parallel processing is what makes Spark so powerful. The next component is auto scaling. Databricks can automatically scale the clusters. For example, current workload requires 4 nodes. Suddenly, data volume increases, so Databricks automatically add more worker nodes. When demand drops, resources are removed. This improves the performance while reducing the cost. Next, we will see the cluster management, how the cluster gets created or cluster creation process. So when a user creates a cluster, the following happens. First, user submits the cluster configuration, for example, runtime version, node size, or number of workers. The next is request reaches the cluster manager in the control plane. So cluster manager communicates with Azure and then Azure provisions virtual machines. The next is Spark runtime is installed, then the cluster becomes available. Now we will see the types of clusters. So first is the all-purpose cluster and it is used for development, interactive notebooks and data exploration. So multiple users can access these clusters. The next is job cluster. The job cluster is created temporarily for scheduled jobs. So advantages are like cost efficient, automatically terminates and isolated executions, commonly used in production pipelines. The next is cluster lifecycle. Databricks manages this entire lifecycle automatically. Next, we'll see the job scheduling architecture. So, how job scheduling works. In enterprise environments, most workloads run automatically. Let's see what happens behind the scene. Imagine a retail company. So, every night, sales data arrives, ATL pipeline executes, data warehouse updates, and reports refresh. The job scheduler coordinates all these tasks. Next, we will see the execution flow. This scheduler can also handle dependencies. For example, task B runs only after task A succeeds. This enables complex production workflows. The next section is security model. So, why security matters? Organizations process sensitive information like financial data, healthcare records, or customer information. So, Databricks provides multiple security layers. We see the identity and access management. So database integrates with Microsoft Entra ID. Users authenticate using enterprise credentials. Role-based access control determines permissions. The next is network isolation. The compute plane runs inside your Azure subscription. This provides network level isolation. Organizations maintain control over their data. Next, we will see encryption. So, Databricks supports encryption at rest and encryption in transit. Data remains protected while stored and while moving across networks. The next is secret management. Sensitive values such as database passwords, API keys, or tokens can be securely stored using secret scopes. Applications retrieve secrets without exposing the credentials. The next is Unity Catalog. Modern Databricks environments often use Unity Catalog. It provides centralized governance for tables, files, models, and data access policies. This simplifies enterprise security management. The next section is real world architecture example. We will see the real world architecture example. So let's put everything together. Imagine a large retail company. Our data sources will be POS system, e-commerce website, ERP system, CRM applications, or IoT devices. All these systems generate data. The next is storage layer. So data lands in Microsoft Azure Data Lake storage. Raw data is stored first. Next comes in Databricks processing layer. So control plane handles workspace, jobs, cluster management, and monitoring. And the compute plane will run ETL pipelines, data transformations, Spark jobs, and machine learning models. So in the analytical layer, processed data flows to Power BI dashboard, data warehouses, and machine learning applications. And what will do the end users? Finally, data is consumed by the end users like business analysts, executives, data scientists, and operation teams. This entire pipeline runs automatically every day. Let's quickly recap. Azure Databricks architecture consists of two major layers, control plane and compute plane. The control plane manages workspace, notebook, cluster management, job scheduling, and authentication. The compute plane executes Spark job, machine learning workloads, and data processing tasks. Clusters are automatically provisioned and scaled. Jobs can be scheduled and orchestrated. Security is enforced through identity management, network isolation, encryption, and governance features like Unity Catalog. So, understanding this architecture is essential for anyone working with modern data engineering and analytics solution on Azure. If this video helped you understand Azure Databricks architecture, don't forget to like, subscribe, and share it with your team. In the next video, we will dive deeper into Databricks clusters, Spark executions, and how data actually flows through the platform step by step. Thanks for watching, and I'll see you in the next one.